All right, so now we're ready to do the experiment part, and just keep in mind you guys should have your lab manual up in front of you so that you can be looking at it to follow along with the steps. All right, I'm gonna start by showing you the equipment. So we have a bunch of assorted cables, we have our Pasco interface, and we're gonna be using Capstone, and then we have our board right here. So this is the Pasco circuit board that we used in a previous lab when we were doing parallel and series circuits. We were playing with these resistors. So today what we're gonna do on our C circuit is we're gonna come over to this side where we have a 100 microfarad capacitor, and we're gonna be connecting it to both the 100 ohm and the 10 ohm resistor. And our goal today is to measure the measured value of this capacitor. So its nominal value is 100 microfarads, but as we know in the real world, it's not gonna be exactly that. So let's start with the first step. It tells me to get a measured value of our resistors. So our resistors are nominal 110, but let's see what they actually are. So I use my multimeter. I turn it on to the appropriate setting, and then I will connect my probes across. I'll do the 100 ohm first. And so it's gonna bounce around a little bit, and I'll wait and see, okay, we're at about 99.8, 99.7 ohms. So this is a number that you guys are gonna record in data table 1. So now that I have that one, I can pull out this guy and plug it in across the 10 ohm resistor, and we can look at our screen and see it's a little bit jumpy. So I'll wait for it to settle down, and it looks like it's about 11.2. So when we do our calculations, rather than using 10 and 100, we're gonna use these values that we just measured. All right, so our next step is we have our box on, Capstone set up, so we're good. And what we have to do is set up the circuit connections. And so let me get this guy unplugged and shut off, move him out of the way, and then start setting up my circuit. So I have a diagram here that is given to me, and I'm going to refer somewhere to notes. Aha. All right, so I need to connect the 100 ohm and 100 microfarad in series. So the first thing I want to do is connect the output voltage. So I want to use this cable, red to red, black to black. And then I am going to connect the red to terminal A, which is this guy, and black to terminal, we're calling it terminal B, which is this guy. So right now I've got it coming in. It can go through this wire, but we've got an inductor sitting in the way. And so we're not wanting to use this, so what we have to do is we have to bypass it. But we have this patch cable that will enable us to do that. So if I take the patch cable and I plug it in to what we're calling C and E, which is these two guys, now I have a current that'll come out of the box, in through this red, go through my 100 ohm resistor, jump into my patch cable to bypass the inductor, come out here and down through the 100 microfarad capacitor before coming back out. So I have a nice complete circuit that puts a 100 ohm resistor in series with a 100 microfarad capacitor. All right, so the next step is to connect the voltage sensor. So what we want to do is measure the voltage across our capacitor right here. So I have my cable for the interface box, and of course cables are always spaghetti, so it'll take me a minute to get it untangled, just like being in lab, guys. All right, so port A, I go in here, plug this guy in, and now to connect it across, I am going to connect the red to this guy and the black to that guy. And I want to do it this way to maintain the polarity. So this is the upstream end, this is the downstream end, because our current flows out the black. So now I've got it connected to measure the voltage across this guy, and I can go to my next step. So I'm ready to collect data. All right, so I come over to the computer and I click the record button, and it will take some data. And it looks like it's scaled pretty well, so I don't need to auto scale it, but I have this fit sitting here, which is currently doing nothing. I don't know if you can see it on there, but there's this light pink line, and that's what it thinks is the fit. So obviously that's no good. So what I have to do is I have to tell it to fit only the portion that I want it to fit. And so we want to just select this portion, which is the charging portion. So again, I just want to show you the voltage. The output voltage is going to be at 0 and then it switches on. So it's a square wave that's either on or off. And so it's a DC current, but it's switching. So we have 0 and then it pops on to 4 volts and sits there and then it goes back down to 0. So this is the charging portion because it's when our switch gets turned on. All right, so I want to use the highlighter tool to select, if it listens to me. Wait, why isn't it working? Aha, there it is. Third time's the charm. Okay, so my highlighter tool, as soon as I put this on here, again, I don't know if you guys can see it, but as soon as I put it on there, that pink line got a lot prettier. All right, so now I'm making a fit. I select enough data to make sure I'm getting it. I don't want to select anything down here because that's gonna mess up my fit. But as long as I select all the points on this curve, I should be good. And now my fit looks like that. It comes across over here, so I've got a nice, pretty fit. And I've got some numbers on here that you guys are going to use to do a calculation. And that will enable us to fill in the table. So I can set my title, R is 100 ohms, etc. And I'm ready to go now and do some data analysis before going to the next part. So at this point, you are able to fill in data table, that you'll answer the questions, which will enable you to fill in data table 1. And so it just comes from answering questions 1, 2, and 3.